All right, so we're going to look at section 7.4 today. Go ahead and make sure you have out that chart again. I'm going to be using it again today. And we've talked about the central limit theorem already, but we're going to look at the central limit theorem as it applies to proportions. And remember, the central limit theorem just says when are we allowed to assume that we have a normal distribution, in other words, a bell curve where we can use this chart. Okay. So first, let's make sure we understand what proportion means. A population proportion would be a portion of a population who have a specific set of characteristics that you're trying to study. So if you were trying to study what proportion of the population has brown eyes, you would need to just come up with kind of a fraction, right? However many people had brown eyes over however many people there were total. That would be considered a proportion because you're comparing brown-eyed people to everyone. All right, so what we're interested in with this kind of stuff is we're interested in when are we allowed to use our bell curve. It's really nice. We have values set out for that. So here is a requirement. In a sample, a random sample, that is, of n individuals. Can't spell individual, apparently. Oh, maybe I can. So what we're going to do is we're going to let x be the number in the sample that have whatever the characteristic is. Then we're going to call the population proportion. So the proportion of the whole group, remember that's what population means, well, we're going to call that P. But sometimes we'll be looking at a smaller group, the sample. And so we call the sample proportion, there's a new kind of notation we're using in this section. And so a lot of mathematicians call this P hat, okay, because it kind of looks like there's a little hat on top of P. But there's kind of the little, upside down V character on top of P, okay? And so, of course, this is going to be what we encounter a lot of times. Instead of having P, because we may not know all the information about the whole population, we might only know it about a sample. And so here is the formula to find P hat, the proportion of the sample. You just take the number of things that have the characteristic over the total number of items. And so here's what we're going to be practicing today. So what is the central limit theorem for proportions then? Like, what does it say? What does it mean? And again, this is just the gist of this is going to be when are we allowed to use our bell curve. So let P hat be the sample proportion for sample size n. And coming out of the population proportion, just regular P. So remember, regular P describes the whole group, the population. P hat describes the smaller group or the sample. So if the following's true, if the number of values times that population proportion is greater than or equal to 10, and also if n times the proportion that did not have the characteristic, notice that's how we could find it, right? P would be the number that had the characteristic, or the proportion rather, and then 1 minus P would be the proportion of things that didn't have the characteristic. But this also has to be greater than or equal to 10. So n times either way, this is a yes and this is a no, 1 times either of those proportions would have to be greater than or equal to 10. Then we can say that the distribution of proportions, sample proportions, or p hat is approximately normal. And if we can show that proportion is true, then if we want the average of all the p hats, remember mu sub something means the average of whatever it is you write as the subscript, but the average of the proportions will be p itself, and the standard deviation of the p hats will look like the following. It'll be the square root of p times the opposite proportion and then divided by n. So just to make sure we're on the same page here, let's write down some steps for computing probabilities. Using the central limit theorem. All right, so number one is to make sure you can even do it. You might have some homework questions that indicate that some things actually can't even use the normal distribution. So remember, n times p needs to be greater than 10, and also n times p minus 1 needs to be greater than or equal to 10. And if so, we can proceed, basically. So most of the questions on Connect are going to ask you, you know, are we allowed to use the normal curve here, yes or no? And if the answer is no, then you're finished. Okay, you actually can't go any further because the answer to the question was no, I can't use the normal distribution. But if you can proceed, the next step is that you need to find the mean of the p hats and the standard deviation of the p hats. Step number 3 is you're going to sketch a picture of the bell curve if necessary. Like if you think it helps you, then you could go ahead and draw it. And finally, we're going to use table A.2 to find the area, the same table we've been using. So let's talk about how we find the standard deviation of these p hats. So here's our old formula for z-score, because remember, that formula, or that table that we're discussing, you have to have a z-score. And remember, z-score can be found by doing x minus mu over standard deviation. So here we're just going to kind of insert the values that make sense for this problem. We're going to have p hat minus the average of the p hats. So it's still value minus average, it just looks weirder. And then we're going to divide it by the standard deviation of the p hats. If you just look at that, that looks really complicated, but it's really not. It's just value minus average over standard deviation, just like this guy was. All right, so let's look at an example. So first, let's say that n equals 234 and p equals 0.75. And this is what I want you to find. I want you to find the probability that p hat is sandwiched in between these two areas / probabilities. Okay, don't make this harder than it is. Visually speaking, we're just saying that p hat is between these two guys. Okay, so let's go ahead and write that out in case we don't like that format or that notation. So this is the probability that p hat is something between 0.77 and 0.81. Remember, on the bell curve, every value has to be 1 or less. All right, so before we proceed, first we just make sure that we can actually use this formula. So you would do n times p, make sure that's greater than 10. Okay, so we've got 234 times 0.75, which gives us 175.5. Okay, clearly this is bigger than 10. Bigger than or equal to is technically the rule. But we have something else to check. We also need to check to see what n times 1 minus p is, not p minus 1 like I just wrote. So n is still 234, but now we're going to do 1 minus 0.75, or just the opposite of 0.75, which is 0.25. Okay, so we end up getting, you can check it on your calculator, 58.8, but notice this is also greater than or equal to 10. So a normal distribution is appropriate and we can proceed. In other words, if the answer would have been no, it's not appropriate, then we would need to keep going. In other words, we would be actually finished with that problem because we can't proceed. We don't have any formulas if it's not a normal distribution for right now. All right, so step 2, remember, was to find some of your key values. Find the mu, which remember is just going to be regular old p. Which is 0.75. That's what we were given, right, in the problem. All right, so now let's find the standard deviation of the p-hats. So it's going to be the square root of p times 1 minus that p, and then all over the total number in the sample, which in this case is 234. Okay, so go ahead and write this out to 4 places. So we'll get about 0.0283. All right, so now let's find the z-score for the 2 p-hats. I need the p-hat of 0.81 and then maybe skip a line. And then I also need the z-score for p-hat equals 0.77. Because if we look up here, those are the 2 values we're trying to squeeze in between. Okay. So let's figure out the z-score. Remember, z-score is value given minus the average and then over the standard deviation. So notice I'm using the 2 values that I just found up above. Remember, when we get z-score, we only need 2 decimal places. So we've got 2.12. Okay, so look at your chart. Okay, remember how we read the chart? I'm just going to do it really probably once. 2.12, you find 2.1, and then you move your finger over to the 0.02, so that's 0.9830. This second z-score is going to be 0.77 minus 0.75 over that standard deviation. And if you work that out, you get 0.71. And then again, look at your chart. The chart is going to give you an area or a proportion of 0.7611. So here's the final answer, and you need to make sure you can write it and understand what it's asking for. The chances that my p-hat is squeezed in between the values of 0.77 and 0.88, the chances of that can be found by subtracting these 2 proportions. Okay, so I'm going to take the proportion for the 0.81, which was 0.9830, and I'm going to subtract the 0.7611, which is the area for the 0.77. And I get a difference of 0.2219. So anytime you're doing a problem where you're going between 2 numbers, remember we find both z-scores, we find the corresponding areas for both, and we subtract those 2. All right, so let's look at a couple word problems. All right, so let's say that the Bureau of Labor Statistics reported in a recent year, not this one, and not right now for sure, but reported that in a recent year that 5% of employed adults had multiple jobs. So they keep up with this statistic because it's kind of a gauge on how the economy is doing. You know, if a lot of people are having to have multiple jobs just for ends to meet, then the government can know that, you know, some numbers may be okay, but this number's not so good. All right, so let's say that a sample of 75 adults is chosen, because the Bureau of Labor Statistics is not going to survey everyone in the United States, right? That's impractical, so they're going to choose a sample of 75 in this case. So my first question is it appropriate to use the normal approximation, in other words, our bell curve chart thing, to find the probability that less than 6.5% of the individuals in the sample have multiple jobs. So we don't just jump into solving this. We actually have to figure out, you know, does it work or not? Is it legitimate? So before we start to use our chart or anything else, first we need to check that n times p is greater than or equal to 10. So notice if you do 75 times 0.05, you get 3.75. Okay. Notice this is not greater than 10. Greater than or equal to 10. The other way would be, but frankly it doesn't matter because this is not greater than or equal to 10. So the answer is no, a normal curve can't be used. This is not an appropriate data set for a normal curve to be used. So we would not be able to assume that it was a bell curve shape or that we would be able to use our chart. That's what that means. Okay. I don't think it's any mystery that I'm probably not going to give you very many where the answer is just no and you can move on. Okay. So let's say, okay, we realize maybe 75 people wasn't quite enough, so we're going to up our sample size and we're going to choose 336. And now let's see if we can find the probability that less than 6.5% of individuals in the sample have multiple jobs. So before we even begin, we're going to check. Okay, so we're going to check is n times p, which in this case we'll do 336 times 0.05, and we'll get 16.8. Notice this is greater than 10, greater than or equal to 10. But you also need to check the other one. So n times 1 minus p is going to be 336 times 1 minus 0.05, or 95%. And actually, sorry about that, this should be 0.05. Because that was the original problem, right? Not 0.05, not 0.5, not half. Half is a lot different than 5%, so change that to 0.05. This answer is still correct. All right, so if you do 336 times the 1 minus 0.05, or 95%, in other words, you're going to get 319.2. This is definitely greater than or equal to 10. So our conclusion, and what Connect will ask you before you can even begin, is that can you use it, yes or no? But we can, because both products gave us something greater than or equal to 10. All right, so we'll go through the list, right? We need to find mu. That's not hard to do. It's given as 5%. So what this means is that if you take the average of enough proportions, you'll get the original population average. That's really what that means. That's why we have to ensure that we pick a significantly big enough sample. So standard deviation looks like the p you're given times 1 minus the p, and then all over n, and then take the square root of that. So again, remember we need to take this out to 4 decimal places because this is not our final answer. All right, so we have our values, and then maybe we want to go back in the original and make sure that it's or make sure how we're going to read our chart. So I'm going to go kind of up here. Sorry, not to part A, to part B. We do want less than, and remember our chart always reads less than. You do need to be aware of that, because if I asked you for greater than, right, you would need to go on your chart, and whatever you read from the chart, you would do 1 minus. So first let's find the z-score. So the z-score for p hat equaling 0.65 or less is going to be z equals the value we're trying to test minus the value we were given, and then over the standard deviation we just found. Okay, so this works out to be 1.26, which actually corresponds to a proportion, if you look on your chart, equal to 0.8962. So here's how we can say our answer. The probability, now that's capital P, probability is capital P. The probability that our little p hat is less than 0.065 is 89.62. Okay, so if you want to kind of know how I want you to word answers, it needs to look kind of like that. All right, so using all the same info, let's answer maybe a couple other questions. What about find the probability that the proportion of individuals in the sample of 336 that we just used out of part B. So find the probability that that the proportion of individuals in the sample who had multiple jobs is something between 0.054 and 0.10. Okay, remember, the population proportion is 0.05. So we're trying to find out what's the chances that in the sample we chose, instead of it hovering around 0.05, it's somewhere between 0.054 and 0.10. Okay, so anytime you have two values and you're trying to go between, that just means find two z-scores, find their proportions, and subtract the two. Okay, so first let's go for a z-score for p hat equaling 0.10. So remember, z-score, value minus average over standard deviation. Okay, notice we get 4.20. So let's talk about what the proportion for this one would be. You might have gotten one in your homework like this, but I don't think we've ever done one in class that's quite this large. Okay, so notice 4.20. Notice my chart stops reading at 3.7. In other words, it's so unlikely that it's this far away. A z-score of 4.2 is actually really large. Anything 3.7 or bigger is actually 0.99949. Okay, and so this is going to be basically as big as it can get. So now let's find the other z-score and then the other proportion. So the z-score would be 0.054 minus mean over standard deviation. Notice this one gives us a much smaller z-score because this number is a lot closer to 0.05. It's a lot closer to what we expected. This number was double what we were expecting. This number's pretty close. And the proportion, if you read the chart here, is going to be 0.6331. So the probability that my p hat stays wedged between 0.054 and 0.10 is going to be the difference between these two. So remember, anytime it's asking you less than, you read the chart as is. Anytime it's asking you for more than, you do 1 minus what the chart says. And then anytime it's asking for between, you find both things from the chart and you subtract them. All right, last one on this problem, and then we'll look at some other stats that were gathered by the Bureau of Labor Statistics. So I want you to tell me, is it unusual for less than 2.5% of the individuals that are in the sample of 336 again to have multiple jobs? Remember, our threshold for unusual is anything less than 5%. But we're not going to eyeball this. We've got to figure out what this is first. Okay, so let's find the z-score for p hat equals 0.025. Make sure you move the decimal place twice. It's not 0.25, that would be 25%. It's 0.025. So here's what the z-score looks like. So it's the value in question minus the average and then divided by the standard deviation we found. So notice this gives us a negative z-score. No surprise, because the value we're checking is less than 5%. And if you look at your chart, turn it over on the other side, right, because we're negative. By the way, it is still asking for less than, so we can, again, read the chart as normal. If it would have asked for greater than, we would have to do 1 minus. But this corresponds to a proportion that equals 0.0179. This is less than 5%. So let's make sure and answer the question. Yes, it is unusual. Now your homework on this section is going to ask you to say the value. You can't just answer yes or no. So you're not going to be able to wing it. You're actually going to have to type in what the value of the proportion was and then tell the computer whether or not it's unusual based on whether it is less than 5% or not. All right, so that was kind of a long problem. We had multiple parts, so let's do maybe one more question, but again, it's going to have multiple parts, so it's going to be kind of lengthy. So again, let's say we got some stats from the Bureau of Labor Statistics. So this bureau has all kinds of stats per year, the unemployment rate for the year, for the quarter, for the month even. They also have kind of what the middle of the road person in America made in their job. So let's look at the median weekly earnings for people employed full-time. Now remember, median is the middle, right? And so a lot of times, remember, we will look at the median, not the average, because outliers can really throw off the mean, whereas they don't really throw off the median. So let's say the middle of the road salary for 2009 for all full-time employees was $755, which means some people made more than that, some people made less than that. All right, so my first question is, what proportion of full-time employees had weekly earnings of more than 755? Notice if you try to find z-score, you're going to get a 0, right? Because you're going to do value minus average, but they're actually the same. But if you think about that this just goes in the middle, then the proportion that are more would just be 50%. Okay, and that's because the median means the middle. So theoretically, it means that 50% are less than the middle, and 50% are more than the middle. All right, so let's say we don't want to survey every full-time working American, so we just take a sample of 150 full-time employees instead. And the question we want to answer is, what is the probability that more than 55% of them worked full-time, or earned more, sorry, not worked full-time, but earned more than that dollar amount, the $755? Okay, this is more than, so if we find we can use the normal distribution, remember we're going to have to read the chart from either the back side of it, or we're going to have to do 1 minus. But we don't proceed unless we're sure we can use it. So we need to check n times p, and we also need to check n times 1 minus p. So n times p is going to be the 150 employees times the 0.5. Okay, remember the original median was 0.5, so this is 75. Notice in this case we're actually going to get the same thing, only because 1 minus 0.5 is also 0.5. So we get 75 in both cases, and notice these are both greater than or equal to 10. So it means we can go on. It means a normal curve, a bell curve can be used. Okay, so since it can be used, now let's find these two guys. So remember, the mu is just going to be the given average, and that was just 0.5. The standard deviation is going to be P times 1 minus P, and then divided by the total number of employees we're studying. Okay, so I'm going to do 5 decimal places on this one, so 0.04082. So sometimes, by the way, if you don't carry the standard deviation out far enough, Connect is going to tell you your answer's close, but it's not quite right. So if you get an error like that, try to go back and look at your standard deviation and maybe carry it out an extra decimal place or two, and usually that fixes the problem. It's just a rounding issue. All right, so we want to go more than 0.55. So first, as always, to read the chart, we must know a z-score. So 0.55 minus the expected 0.5, and then divided by this standard deviation that was 5 digits long. So we end up getting 0.122. Which corresponds on the chart to a proportion of 0.8888. But what I want, remember, is more than, so I'm going to find the probability that p hat is greater than 55% is going to be 1 minus that value I found on the chart, or 0.1112. Okay, so I didn't ask you it, but if I did ask you if this was unusual, you would say no, right? Because 11% is more than 5%. All right, C. What is the probability that less than 60% of the sample of 150 employees earn more than $755 a week? So again, this is a more than problem. Okay, so we'll keep that in mind. So let's find the z-score. So the z-score for p hat, or FAT for short. Just kidding, nobody calls it that. But the z-score for p hat is going to be 0.60 minus the 0.5, which is the mean, divided by the standard deviation. And so we're going to get 2.45 for our z-score. We're going to look on our chart, and that corresponds to a proportion of 0.9929. But remember, don't forget I'm doing more than. So if I want the probability that the p hats are more than 0.6, then I would need to do 1 minus 0.9929, which is pretty unlikely. So 0.0071. Okay. Notice if I was asking you for, hang on a second, let's fix this. So this isn't the answer. So let's go back, and I made a mistake. When I underlined the more than, that was just the 755. Okay. What I really needed to pay attention to is I'm asking about less than 60%. So always look for the phrase that's in front of the percentage. Okay. So in all reality, I don't really need to do the 1 minus here. Okay. So you can just erase that. It would actually just be this. Because remember, in the original problem, it was that they earned more than $755. So that's not where you need to look for the more than, less than. It actually needs to be in front of the percentage sign. All right, so last part and last question for this section, I think. I think we have the hang of it after this. So I want you to maybe pause the video after I write this down. Try to do this on your own. But what is the probability that between 45% and 55% of the sample of 150 that we took earned more than $755 per week? Okay, remember, anytime you see the between, you need to know your strategy, right? We need to find two z-scores, look on the chart, and then we can subtract the two. Okay, so like I said, pause the video and see if you can actually get your chart out and work this out, and then only play it once you've finished. But once you figure, notice we already figured out some of this, so you might look for this on Connect. We already found out the probability that p hat would be less than 0.55. Like that was one of the ones we already did in one of the previous sections. So be on the lookout for things you can, pull from previous sections. So we found this one in part B. We already found the probability that p hat was less than 0.55 was 0.8888. But we don't know the other one. That's a new one. So now let's find the z-score for p hat equals 0.45. So the z-score is going to be value minus average divided by standard deviation. And this works out to be about negative 1.22. Which corresponds, if you look at your chart, corresponds to 0.1112. So the final answer, and this is how I want these written, the probability that p hat is sandwiched in between 45% and 55% is going to be whatever you get when you subtract the two proportions that we got. And so that would be 0.776. So just remember, in this section on the homework, first you have to make sure you can even use this chart. Okay, so first you need to check and make sure that you can use the chart, and then once you can, you're really just doing a lot of what we've already done in 7.1 through 7.3. You're reading the chart, okay, and you read it as it is for less than problems and 1 minus for greater than or more than problems.